We want to welcome you to this session. If you have not watched any of our videos, please watch, like, and subscribe for more. And do you know why you should do that? Because if you watch our videos, if you take our classes, you will understand why everything happens in mathematics. We don't leave any stone unturned. We get to show you why the results you get are the way they are. And today we want to do something very interesting. You have been using the quadratic formula, but the question is, do you know how the quadratic formula was obtained? How was it established? We are going to show you today. Pay attention as you're going to be understanding all the details with regards to that. Now, the quadratic formula is established from the quadratic form itself, which is this: ax plus ax squared plus bx plus c. This is it. It is from this very form of the quadratic equation that we're going to get this quadratic formula. Now let's take a step-by-step guide. As we're solving this problem, we'll be explaining how some things are happening. We'll be recalling some laws that you know, and we apply them so that you see them clearly. Now let's start. The quadratic form is giving us ax squared plus bx plus c equals to 0. Now let's divide all these by a. Let's divide it by a. If you divide here by a, you divide here by a, you divide here by a, you divide here by a. This will cancel this. And this automatically will give you 0 here. So what do you have left? You have x squared plus b over ax plus c over a equal to 0. This is what you have. Let's move this one to the right hand side. If we do that, we're going to be having this square plus b over a x equal to minus c over a. How should we proceed? We are going to be adding half the coefficient of x to both sides. Coefficient of x. So if we do that, what are we getting? We are having something like x squared plus bx over a. We are adding half the square, and half the square is b over 2a all squared equals to, we have minus c over a plus b over 2a all squared. By half the square, the coefficient of x here is b over a. Half of b over a is 1 over 2 of b over a, which is equals to b over 2a. So I want you to understand why these things are the way they are. So if we are to proceed from here, the whole of this is the same thing as x plus b over 2a all squared. I know you'll be wondering how that is possible, but let's show it, because what you have is x plus b over 2a all squared. What this means is you're going to have this in two places. That's what it means. In two places, x plus b over 2a in two places. So by expansion, if you want to expand this, you're going to be having x squared, because this will multiply this, plus x will be multiplying this. You have b over 2ax. This will go with this. You now have plus b over 2ax again, and then this will multiply this. You now have plus b over 2a all squared. That's what it means. So this is x squared plus b over 2ax plus b over 2ax is going to give you 2 of it. 2 of b over 2ax, then plus b over 2a all squared. You see, these two, we cancel these two. It brings you back to what we have before as x plus b over ax plus b over 2a all squared. So we have established that this is true. So if we should come back here, we can say that the whole of this can be written as this. This is now equal to this can be written as b over 2a all squared minus c over a. Nothing has actually changed here. Nothing has changed. Now, in law of indices, you know that if you have a over b all squared is the same thing as saying a squared plus b squared. This is established. So coming back here, this can be written as x plus b over 2a all squared equals to, this can be written as b squared all over, first 2 squares is going to give you 4, a squared is going to give you a squared minus c over a. Now to proceed with this, we are going to break this down so that we get the complete result of this place. So what do we have? C. So we have b squared 4a squared minus c over a. How do you do this? This is a fraction that is subtracting itself. Now the LCM here, we are going to be using 4a squared. What's the idea? The idea is this is going to multiply this and then divide this. This same one is going to multiply this and divide this. Now how does it happen like that? 4a squared multiplied by b squared will be 4a squared b squared. If you divide it by 4a squared, 4a squared will cancel 4a squared. So what you're having here is b squared minus 4a squared times c, 4a squared times c all over a. One of the a's here will reduce one here. So what you have here is 4ac. So the whole of this place, right hand side, is going to be turning into what we have the other side. So our x plus b over 2a all squared will be equals to b squared minus 4ac all over a square, because that's what we have this square. So we have established this very result here. This and this is the same. So how do we continue from here? This is the same as saying we're going to take the square roots of both sides. Now let's get our results first before we put it here so that it will be clearer for us. Is x plus b over 2a all squared. So if we take the square root of this and this will cancel. Is equals to plus or minus the square root of b squared minus 4ac all upon 4a squared. So this is equals to x plus b over 2a, as what is left, is equals to plus or minus the square root of b square minus 4ac minus 4ac all upon 4a square. So this have been reduced to this. So we'll come back here. What we have here is x plus b over 2a equals to plus or minus the square root of b square minus 4ac all upon 4a square. That is what we have. That is what we have. But is this where this is going to stop? The answer is no. Proceeding from here, you know by a law of indices that if you have the square root of b over a, or a over b is the same thing as the square root of a all over the square root of b. So looking at this can also be written as the square root of b square minus 4ac all over the square root of 4a. If you look at it, this square root of a times b can also be written as square root of a times square root of b. It therefore means that the denominator here can be written as the square root of 4 times the square root of a square, such that this will give you 2 and this will give you, because this will cancel this, will give you a. Our denominator will now turn to 2a. So we can say that this place will now be equal to all right, x plus b over 2a equals to plus or minus square root of b square minus 4ac all over 2a. And what we are looking for is the value of our x. So we're going to be moving this one to the right hand side. So we have x is equals to, when this moves, it becomes minus b over 2a plus or minus the square root of b square minus 4ac all over 2a. Now what do you notice? You notice here that the right hand side has the same LCM, the same denominator, which is 2a. It therefore means that we can write this as x equals to minus b plus or minus the square root of b square minus 4ac all together 2a. This establishes the formula you always use to solve your quadratic equation. That brings us to this very first so at this level, you agree with me that you know all the nitty-gritties of solving these problems. We have used this side to show you how all those things were obtained, and I believe you'll be able to get the result. Thank you for your time. Like and subscribe. Bye-bye.